Hi guys, I'm back with my lectures. I'm Mr. Joseph, your chemistry teacher. Today's lecture is a continuation of our previous lecture on lattice energy. From our previous lecture, we are meant to understand that lattice energy is the energy release when 1 mole of an ionic solid, an ionic compound, is formed from its gaseous ions under standard condition. And during this process, huge amount of energy is released because an ionic compound is formed, a bond is formed, and during bond formation, energy is what? Energy is released. So today's lecture we'll be looking at the factors affecting lattice energy and ionic size stroke ionic radius. There's the relationship between lattice energy and the ionic radius, ionic size. Then lattice energy and what? Ionic charge. That is the relationship between lattice energy and ionic size. Now, what are the factors affecting lattice what? Lattice energy. And we all know that lattice energy arises as a result of the electrostatic force of attraction between what? Oppositely what? Charged ions, and they form what? A crystalline lattice. Now, the value of lattice energy is affected by the size and the charges of what? Of the ions. So these are the two major factors that affect what? Lattice energy. That is ionic size and what? Ionic charge. Now, going by Coulomb's law, which is before us, F signify what? Electrostatic force of attraction. K is a constant. Q1 and Q2 are the charges, and R is the square of their distance apart. Based on Coulomb's law, the electrostatic force of attraction between two bodies is directly proportional to the product of their what? Of their charges, and inversely proportional to what? The square of their distance what? Apart. So we can use this to explain the relationship between lattice energy and ionic charge and ionic radius. Some will say the force is directly proportional to the product of what? Their charges. That means as the electrostatic force of attraction increases, the product of their charges will increases. As it decreases, the product of their charges decreases. So the same thing with lattice energy. As the ionic charge, as the charges of the ions, once it increases, the lattice energy will increase. Once it decreases, the lattice energy will decrease. That is just the relationship. That the lattice energy is directly proportional to the product of what? Their charges. So that is to the ionic what? Ionic charges of the oppositely what? Charged ions, and inversely proportional to the square of their distance apart. That is the ionic size or the ionic radius. So it is inversely proportional to. That means an increase in the force of attraction. That means there will be a decrease in what? The ionic size or ionic radius. A decrease in the electric force of attraction, there's going to be an increase in the what? Ionic size or ionic what? Radius. So the same applies to lattice energy. So lattice energy, that means lattice energy is inversely proportional to the ionic size or the ionic radius. So as the ionic size or ionic radius decreases, the lattice energy increases. As the ionic size or ionic radius increases, the lattice what? The lattice energy what? Decreases. So looking at lattice energy and ionic size, it discovered that as the size of the ion increases, the lattice energy becomes less exothermic. That means the lattice energy decreases. And this is because the positive and the negatively ions are further away from what? One another, from each other. So there will be what? A decrease in the electrostatic force of attraction between the oppositely what? Charged ions, and making it easier to separate what? They separate the ions. That means the ionic bond is not very strong, and the ionic compound is what? Is less stable. So the effect of ionic size. So looking at the table, you can see the effect of what? Ionic size or ionic radius on what? On lattice what? Lattice energy. Look at the lattice energy of sodium chloride, energy of sodium chloride, sodium bromide, sodium iodide. As you go down the group, what happens is that what? The ionic size of the halide, chloride, bromide, and what? Iodide increases, and what? And the lattice energy becomes what? Becomes less exothermic. That means there's a decrease in what? In the lattice energy. There's a decrease in the electrostatic force of attraction between what? Between the oppositely what? Charged ions. So the lattice energy becomes what? Less negative. It becomes what? Less what? Exothermic. It becomes less stable. So there's a decrease in the lattice energy as a result of what? Increase in the ionic size or what? Ionic radius. So the ionic size increases, there will be what? A greater distance between what? The oppositely charged ions. So the attraction between the ions decreases, and the lattice energy what? Becomes what? Less negative, becomes what? Less exothermic, and vice versa. So you can see that sodium chloride is more stable than what? Sodium bromide. Sodium bromide is more stable than what? Sodium iodide. So the ionic bond gets weaker as you go down the group, and it's as a result of what? Increasing the what? Ionic size or what? Ionic radius. So that is the effect of what? That is its effect on what? On lattice what? On lattice energy. So still on lattice energy and ionic size, as the size of the ions decreases, that is the ionic radius decreases, the lattice energy becomes more exothermic. There's an increase in lattice energy because the positive and the negatively charged ions are closer to one another. So there's an increase in the electrostatic force of attraction between the oppositely charged ion, making it difficult to separate the ions. That means the ionic compound becomes what? More stable, and the electrostatic force of attraction gets stronger, so the ionic bond what? Increases, because it becomes what? More exothermic. So as the ionic size decreases, the lattice energy becomes more exothermic. There'll be a greater attraction between the oppositely charged. So looking at the graph before us, this is a graph of lattice enthalpy against what? Against ionic radius or ionic size. So looking at the graph before us, it clearly states what? The relationship between the lattice energy and the ionic size or ionic what? Radius. As you can see, that as you go down the group, these are group 1 elements, the ionic size increases down the group, and the lattice energy becomes less exothermic. You can see that lithium has the smallest ionic size, and it has the greatest what? Lattice what? Enthalpy. It becomes what? Has the greatest what? Lattice enthalpy. It becomes what? The most exothermic. So as the ionic size decreases, the lattice energy becomes what? More exothermic. The same thing for the fluoride. You can see fluorine, the lattice energy of fluorine, chlorine, bromine, or what? Iodine. So as the ionic size or ideal radius increases, the lattice energy becomes what? Less exothermic. So there's less attraction between what? The oppositely what? Charged ions, which will not affect what? Affect how stable the ionic compound will be. So that is the effect of what? Lattice energy on what? On the size what? On the size of what? Of the what? Ion. Now looking at the lattice energy and charge on ions. So as the ionic charge increases, it's just trying to explain the effect of ionic charge on the lattice energy. So an increase in the ionic charge brings about an increase in the what? Lattice energy. What that means is that the lattice energy becomes more what? Exothermic. At this point, there is a greater electrostatic force of attraction between the positively metallic ion and the negatively charged non-metallic what? Ion, and therefore more energy is needed to separate them. No more energy is needed to separate such a compound. So as the ionic charge increases, the electrostatic force of attraction increases, the ionic compound becomes more what? More stable at that point, because there's a greater attraction between the positive and negatively charged ion. Now looking at the figures below, you discover that this is the lattice energy for magnesium oxide and lithium fluoride. You discover that the lattice energy of magnesium oxide is more exothermic compared to the lattice energy of what? Lithium or lithium fluoride. The reason is because magnesium oxide has a charge of what? +2. If you look at magnesium, it has a charge of what? +2, Mg2 plus, then O2 minus. So it has a greater ionic charge compared to lithium fluoride, which is what? +1 and F minus. So you can discover that what? The lattice energy for magnesium oxide is greater than what? The lattice energy for what? Lithium fluoride. So the lattice energy is more exothermic. So magnesium oxide have a stronger electrostatic force of attraction between its ions, and magnesium oxide have a stronger what? Ionic bond compared to what? Compared to lithium what? Lithium fluoride. So as the ionic charge increases, the lattice energy becomes what? More exothermic. So that is the effect of what? Of ionic charge on the lattice energy. And as the ionic charge decreases, the lattice energy becomes less exothermic. The electrostatic force of attraction between the oppositely charged ion decreases, and also the ionic bond also decreases. So before us is just a summary of the effect of ionic charge and also ionic size on lattice uh, energy. With increased charge on cation, two factors increase the magnitude of the lattice energy on a cation, and the two factors are what? Increased charge, which is what? Increased charge, which is the ionic charge. It will lead to what? Greater attraction, more exothermic lattice energy. Decreased size, it will lead to greater attraction between the oppositely charged ion, more exothermic lattice energy. Now, with increased charge on an anion, two competing factors come into play. Increased charge, which is greater attraction, and more exothermic lattice energy. Increased size, less attraction, less exothermic the lattice energy. So it's as simple as ABC. So the two major factors that affect lattice energy are the ionic charge and the ionic and the ionic size. From Coulomb's law, lattice energy is directly proportional to the ionic charge. As the ionic charge increases, the lattice energy increases. As the ionic charge decreases, the lattice energy decreases. That is the charges between the oppositely charged ion. Based on Coulomb's law, the electrostatic force of attraction between two bodies is directly proportional to the product of their charges. So the same thing with lattice energy. The lattice energy is directly proportional to the product of the positive and the negatively charged ions, and also inversely proportional to the square of their distance apart. That is the ionic size and the ionic radius. So it is as simple as ABC. Those are the two major factors that affect the lattice energy, and also affect the strength of the ionic bond in an ionic compound. Also affect the electrostatic force of attraction between ionic compound. So it's as simple as ABC. Just go through it and feel free to reach out to me if you encounter any difficulty. Once more, I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Please subscribe to my YouTube channel. Go to the comment section and give your feedback. Please give your feedback. I'm always there for you and will always be available for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So I'm Mr. Joe, your chemistry teacher. Thank you for listening. Please reach out to me if you encounter any difficulty. I'm always there for you. Once more, I'm Mr. Joseph, your chemistry teacher. Thank you very much.